So in this video, I'm going to provide a physical example of the controllability of a system. So let's consider this fluid dynamic system. So we have this system, and these three pictures are nothing, just the same system at different time. So this one is at time t0, and this one is after time t1. So we have, say, three different states: x1, x2, and x3, and x is our state vector. So if we consider the first two compartment, say we have our first state defined by x1. So at t0, the situation is this. The question is, can we control x1? The answer is no, because there is no way we can reach x1, because x1 is determined by the air particles that are coming from the reservoir, and this reservoir on the top is actually closed. So after time t, when we reach to t1, this air particle condition will definitely change. Some of the air particles will go out, and we will have, basically, there should be less particles, and this is we have no control on this, because this is all by its own dynamics. Now let's consider the next two compartment, x2 in the second one and x3 in the last one. So they have their own air particles. Now the question is, can we control the states x2, or can we control the air particle or the density of air inside this compartment? Alternatively, if we what is basically defined by x2, can we do that? The answer is yes, because we have a opening here, and we can basically blow some air here somehow, say using a compressor, and that's how we can manipulate it. So here, say we have a blower, and we can blow some air or air particles, and that is going to be our input U1, and that is going to go inside that and going to change it. So even though x1 is not controllable at all, x2 is controllable, because we can reach that using control U input. So we can see that we have some air particles coming out of this input blower, and we can basically adjust the input in a way that a certain density within this compartment reaches. So we can define, or we can actually achieve our desired state within this compartment. Now the question is, what about this compartment x3? So x3, it started with few air particles, and it has also an entrance here. So now the question is, can we actually control this? Because there is no direct opening with this last compartment, so technically we cannot directly control x3. But do we have any control on x3? The answer is yes, because some of the air particles will actually come through here and mix with this. And so if we calculate the required airflow for achieving a desired state, we can, to some extent, because we can basically calculate the opening and calculate the volume, and based on that we can flow our air, so that we can send certain number of air particles within this room. So yeah, x3 we can control as well. So we can see this is x3, and this was the original one, and some of the air particles from the blower will reach here as well. So, and we can kind of manipulate the state x3 at time t. Not exactly the same way as we can do x2, but to some extent in an indirect way. So we can see that here, out of these three states, x1, x2, and x3, x2 and x3 are our controllable states, and x1 is uncontrollable state. So a system, this whole system, now if we ask, is this whole system is controllable? The answer is no, because for controllability of this system, we need control over all the states. So we need to have control over x1, x2, x3, but we do not have control on x1, so it's not fully controllable. But is it partially controllable? The answer is yes, because we have control over x2 and x3. In fact, if we define a system around this last two compartment, that system will be fully controllable. And if we define a system on this around this first two compartment, that will be uncontrollable. So this full system can be divided into two subsystems, which is controllable. One of this is controllable and another is uncontrollable. And this division in control system is called Kalman decomposition.